Today we'll be simplifying radicals with variables. When we simplify radicals with variables, we just need to determine the numbers of pairs when we're working with square roots. So all we need to do is divide the exponent by 2 and we'll know how many pairs are underneath the radical. When we're dealing with an even exponent, there's an even number of pairs, so everything goes away from underneath the radical. So x squared is x times x, so 2 divided by 2, how many pairs? We have 1. X to the 4th, we have 4 pairs, we divide by 2, we have 4 x's divided by 2, that leaves me 2 pairs. X to the 6th divided by 2 is 3 pairs. Now when we have an odd exponent, we're going to leave one variable left under the radical. So here we have the square root of x to the cube, so we take the exponent 3 divided by 2, 1 goes out, 1 pair, and 1 variable stays underneath. X to the 5th, we divide by 2, so that's 2 with 1 left over, meaning 2 pairs underneath come out, and 1 variable left over. And x to the 7th, 7 divided by 2 is 3 with 1 left over. Square root of 16p can be rewritten. Number 2, square root of 64b squared. Square root of 8 times the square root of n squared. Square root of 4 times the square root of 2 times n. Still can be simplified to 2 square roots of 2. And on the outside, we have 2n square roots of 2. Square root of 48r4 is the square root of 16 times the square root of 3 times the square root of r to the 4. 4 square roots of 3 r squared. So 4r squared is the square root of 3. Square root of 81 times the square root of a to the 4th times the square root of b to the 5th. Those are perfect squares, a 9 and an a squared. 5 divided by 2 is 2 with 1 left over. So our coefficient is 9a squared b squared and the square root of b. Number 6, the square root of 48 times the square root of x to the 3rd times square root of y to the 4th is 16. Square root of 16 times square root of 3. And number 7, we have a coefficient on the outside, so that's just going to stay there. We're going to multiply